In this video, we're going to be covering the 6.2 material working with multiplication properties of exponents. Should be noted that before we jump into the properties themselves and how they work and all of that, I do have some food for thought and some warnings and heads up for you before we dive into this section. Please make sure you are taking time to correctly identify the base for exponents. What very specific thing is being raised to the second power, third power, fifth power, 10th power, things like that. This is essential with this entire section because if we don't correctly identify what that base is, everything else in the problem falls apart and we will get wrong answers very, very quickly as a result of that. As a quick reminder about exponents, if we have something like x raised to the a power, the variable x here is considered to be the base, or it's the based thing in some regards, in some way it's described. And a, the little number hanging out up top, that is considered to be the exponent. Exponents also, as a generality, are a shortcut to denote repeated multiplication of the base. So this would be x times x times x times x a many times. It could be 3 times, it could be 5 times, it could be 20 times, whatever that number may be there. That's dependent on the exponent. So a quick refresher there on exponents and what those look like right here. But this part up here, this particular bullet point, make sure this is your top priority as you are going through these problems. This will make or break every single thing that we do moving forward in this video. Now the three main properties that we are going to take a look at in this video, and there are more that we'll get to later on in other sections, but for this video we have these three. The product rule, the power rule, and the product to a power rule. The product rule states that if I have two bases that are the same, in this case a, and those bases are multiplying together, we have denoted here, then the exponents are going to add together. So if this was a to the m power times a to the n power, the result would be a to the m plus n power. And I would just add these two numbers together here, whatever those may be. They could be 1 and 2, they could be 4 and 10, they could be 6 and 7. Whatever those numbers are, they're just going to add together, and that new number is going to be my exponent. I then have the power rule, which says if I have a to the m power, that is inside parentheses, and all of that is being raised to the n power, then that means that the two exponents are going to multiply together, and the base will stay the exact same. We can rewrite the power rule into the product rule and then use that to get to our answer, but the power rule is just a shortcut version of using the product rule if I have repeated exponents being raised to powers. And our last one that we have is the product to a power rule, which states that if I have a times b, that is inside a set of parentheses, and that set of parentheses is raised to the m power, then a, and whatever exponent it has, is going to be raised to the m power, and b, to whatever exponent it has, is going to be raised to the m power as well. And I effectively get two instances of the power rule showing up. The result in this case, the general example we have, being a to the m times b to the m. The exponents will again multiply together here. We're going to go through a few different ways that these can be denoted with our first few examples, and you are welcome to write the problems out for yourself either way or any way that you would like to, but I should note that these are designed to be shortcuts. So the sooner we can get these nailed down and get familiar with them and get comfortable with them and have them memorized, the faster you're going to be able to go through these problems as you're looking at them on your own homework. So, the last note that I will make with this, you do always have the nuclear option of always expanding out and simplifying the bases. I'll show you what I mean by this with example 4, and there's nothing wrong with it, but I will find very oftentimes that people get these wrong because we get so many things written out and it kind of becomes a little bit messy. So keep that in mind as we take a look at a couple of these examples here. Now I have 10 problems that we are going to go through. The first two examples we're going to go through at once, and I have a third kind of mini example or bonus example that goes on with these because there is some pretty important stuff to note here when we have negative signs showing up and exponents. So let's go ahead and dive into these examples down below here. Starting off with our first two examples and our bonus one that we have right here, we're just going to go in and use our standard properties for exponents at the very beginning here. I have a base of 6, and that's being raised to the second power, which means if I were to expand this out, I would have 6 times 6. And then I can simplify that down to be 36 by multiplying those two numbers together. And I have my final answer. Now, the tricky part shows up with our second example and this bonus example, specifically when it comes to working with this negative sign and the exponents that are here. When we are looking at this, we want to make sure we're being very careful with what is the base and what does that encompass as being affected by the exponent. If we look at our first example, or our second example right here, negative 6 to the second power versus the quantity negative 6 all raised to the second power. With our second example, only the number 6 is being raised to the second power. The negative out front is just sitting there. So I'm taking the negative of whatever 6 to the second power is. So I can write this out and denote this as negative 6 times 6. And I end up getting negative 36 as my answer here. However, when that negative sign is inside a set of parentheses like we have with our third example, or the bonus one I should say that we have right here, what is being raised to the second power? It's this set of parentheses that's being raised to the second power. So everything inside of the set of parentheses is going to multiply with everything inside of that set of parentheses. If we were to expand this out and actually write it out, it would look like this. The quantity negative 6 times the quantity negative 6. So because the negative is inside of the parentheses, it is therefore included with this exponent property. So when I expand this out, I get negative 6 times negative 6, and negative 6 times negative 6 gives me a positive 36 for my final answer. So when you are going through problems and you have negatives showing up in or around or near the bases, make sure you are taking extra time to pause and really think on, does this negative sign get included with the exponent or does it not? And also look to make sure, do we have that negative inside of parentheses or not? I think that's the biggest giveaway with if we are or aren't going to be applying this negative sign or not. So be on the lookout for that as we take a look at some future examples here. Looking at our official third example, we have the quantity 3 over 5 being raised to the third power. Now I'm going to go through and show two ways that you could write this out for yourself. I do not care if you're in my class which way you would like to write this out for yourself. Whichever is easiest for you, you're welcome to use. So the first route that we're going to take, we'll kind of split this up here into two parts. The first route you could take is by expanding this expression out. I have everything in this set of parentheses being raised to the third power, which is the same as saying everything in the parentheses multiplying by itself 3 times. Now you're welcome to use this method if you'd like to. I think it can get a little, I don't know, we can run out of space really quickly if we use this for all of the problems. But it does a lot more clearly denote that we have fractions multiplying together, and when I do that, I can multiply straight across in the numerators and straight across in the denominators, and that's going to give me 9 over 125. Doing some calculations with that off screen, but you're welcome to use a calculator if those numbers get a little bit bigger and freakier like that. Now we do have the alternative way of going through this, which is to alternatively say, all right, I have a fraction raised to the third power, so that's the same as saying the numerator being raised to the third power divided by the denominator being raised to the third power. 3 to the third power, that's going to give me 9, and 5 to the third power is going to give me 125. And I'm more than happy and more than welcome to expand this numerator out to be the exact same as what I have written over here, because these are the exact same expression. Either way, whichever route you take, you are going to be getting to the same answer of 9 over 125. And again, if you are in my class and you're watching this video, either of these methods are perfectly acceptable as far as I'm concerned for showing your work and getting to the final answer. Looking at example 4, we are given the expression n to the third power times n to the 8th power. Now I'm going to denote two ways that you can write this out just to show that there are two ways that we can solve this. There are probably more if you look up and find other methods online, but I at least want to show two ways of writing this out for this example. For future ones, I'm just going to go through and simplify them using one particular method, but be aware that there are multiple routes that you can take to show how you get to your final answers with these. So let's try expanding this thing out. I want to write n to the third power expanded and n to the 8th power expanded out. So if I'm writing that down below, I'm going to get n times n times n for n to the third power times 1, 2, 3, 4, 5, 6, 7, 8. I think I need to extend this blue line out here a little bit more. Something like that. Okay, so now I have a whole bunch of n's multiplying together. I can literally count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I miscounted here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I can count, don't worry. And I'm going to get n to the 11th power because it's multiplying by itself 11 total times. So this is one route that you can take. Hopefully your counting skills are better than mine, because clearly mine are subpar, which begs the question, why am I making these videos? But hey, I guess I'm trying at least, right? Now alternatively, instead of going through and having to write all of this out and then count things up and then maybe miscount them like I do, we have the alternative of using the product rule that we went through at the very beginning with our different properties. I noticed that the n's, which are the bases, are multiplying together, which means the product property is in fair play here. So if I'm using the product property, that means the exponents are going to add together. So I get n to the 3 plus 8 power, and 3 plus 8 is going to give me 11. We're seeing that we have two routes here, again, perfectly acceptable to be used to get to our final answer. On the homework or on a test, again, I do not care which method you would use, though I strongly recommend that we get comfortable with this product rule, because let's take this expanded form as an answer. All it takes is someone putting a 1 or a 3 there, or maybe it's a 4 there, and suddenly you're having to write out 31 n's and then another 84, and I just don't think there's enough paper to do all of that and make it nice and neat and organized. So you're welcome to use this, but I would very much get comfortable with using our shortcuts and properties, which is the main thing that we're trying to focus in on and use in this particular section. With example 5, we are given the expression, the quantity a to the second power times b to the third power. All of that is multiplied with a to the 10th, b, c to the third power here. Okay? First and foremost, we're noticing that we have multiplication happening between these two sets of parentheses. So this could be written out effectively as a squared times b to the third times a to the 10th times b times c to the third power. I don't have any exponents showing up outside of the sets of parentheses, so great, I can just rewrite it all multiplying together. Now from here, I'm looking at where do I have bases that are the same. So I notice that I have some a's that are going to be multiplying together, I have some b's multiplying together, and I have c at the very end here. Now it's your choice if you want to take this step to rewrite the problem like I'm doing now. You don't have to, but I think it can be helpful just to see, hey, here's the similar bases multiplying together, so I can apply the product rule. And now that I have the same base multiplying together, the exponents are going to add, which is going to give me, for my first part, a to the 12th power. The b's are multiplying together, b to the 3rd power times b to the, there's that invisible 1 that's hanging out there. If you need to write that in for yourself, you're welcome to do so. So b to the 3rd times b to the 1st power, the exponents add, and that's going to give me b to the 4th. And then the c to the 3rd power, well, there's nothing multiplying with it that is also a c, so it's just going to fall down exactly as it was, and it's going to stay the exact same. This is not uncommon with some of these problems, is that we'll be given an extra variable that turns out it can't actually multiply with anything and have its exponent change, and that's perfectly fine. We're just going to leave it exactly as it is, all the way down to our final answer. Absolutely nothing wrong with that. With example 6, I'm being given the expression t squared being raised to the 5th power. Now I know I said I wasn't going to show multiple ways, but I do want to at least show how the power rule works with the shortcut method versus expanding it out. So we have an exponent being raised to a power. If we are going to apply the power rule exactly as it states, we are going to therefore multiply these two exponents together. And my result in doing that, if I were to write that out, would be t to the 2 times 5 power. 2 times 5 is going to give me 10, so I get t to the 10th as my final answer, and I can be done there. Now, if you were to expand this, we're not going to fully expand it, but I at least want to show the parallel between the power rule and the product rule and how they relate to one another. I have t squared inside of a set of parentheses, and that whole set of parentheses is being raised to the 5th power, which means if I wanted to expand this, I would have t squared times itself 5 total times, like we're listing out here. And now, I could apply the product rule, which states that if the bases are the same and multiplying together, which is what they are doing, parentheses next to each other denotes multiplication, then I can add the exponents together, 2, 4, 6, 8, 10, and I get t to the 10th power either way. Again, I would highly recommend we only use this expansion version with it, maybe once or twice if we really need to, but other guys really nail down getting those shortcuts with the power rule itself applied here. It's going to save us a lot of writing by comparison, and I'm hoping that having these side by side will demonstrate that. For example 7, we're starting to get into some trickier waters here where we're starting to have to mix and match and keep track of things a little bit more. We're now going to have coefficients and variables showing up, so there's more to keep track of. So we have the quantity -3b to the 7th, all raised to the 3rd power. Now note that this negative is inside of the parentheses, which means it is going to be included in being affected by this exponent of 3 out here. Now you have a couple ways that you can go through and think on and write this out for yourself. One of the things that I like to do is think of every single thing inside here, because it's all multiplying together, as individually being raised to the 3rd power, effectively applying the product to a power rule. And the way I like to go about doing it, and I recommend doing this, is to write out each individual thing inside the parentheses being raised to the 3rd power individually. So that would look something like this. -3 in parentheses raised to the 3rd power times b to the 7th raised to the 3rd power. So notice how I'm still having everything inside the parentheses raised to a 3rd power, the way it's written, but I can now look at just this coefficient to the 3rd power and then just this variable to the 3rd power and deal with them individually versus having to deal with it all at once. I think this generally tends to make solving and finding answers a little bit easier, especially if we break it down into nicer, smaller pieces. So negative 3 raised to the third power. A negative times a negative is a positive, but times another negative, that's going to make it negative yet again. 3 to the third power is going to give me 27, so I'm going to have negative 27 showing up from these things expanding and multiplying together here. You're also welcome to use a calculator or expand it off to the side here if you'd like to. We have b to the 7th raised to the 3rd. I can apply the power rule here, which states that exponents raised to powers multiply together, so that gives me b to the 21st power. And everything is multiplying together, so I can just write it as one single thing here. And there we get to our final answer of negative 27 b to the 21st power. Okay, number 8. We are being given the quantity 9x squared y, all being raised to the 3rd power. So I'm going to be applying the product to a power rule. I have a whole bunch of things multiplying together here. I have a product, and that all is being raised to the 3rd power. So I'm going to do very similar to what I did with example 7, which means I'm going to look at just the 9 raised to the 3rd power, just the x squared raised to the 3rd power, and just the y raised to the 3rd power. And I'll deal with each of those individually after I've done that quick rewrite. I highly recommend, if you are having any issues with the product to a power rule and keeping track of what does and doesn't get affected by this 3rd power and what changes, I definitely recommend you take this one extra step to rewrite it out for yourself. I think this makes it much clearer what is going on in the problem. Now 9 to the 3rd power, you can apply your calculator if you would like to. I did that off screen, and I'm going to get 729. X squared raised to the 3rd power, that's going to be the power rule, so the exponents are going to multiply together, and I'm going to get x to the 6th power. And then y raised to the 3rd power, well, what's the exponent that's showing up here? I have that invisible 1 that's hanging out there with that y. So 1 times 3, that's going to give me 3. So I have y to the 3rd at the end. And my final answer is going to be 729, x to the 6th, y to the 3rd power. Example 9 is giving us the quantity 2/5 a to the 4th b to the 3rd times 15 ab to the 3rd power. So we have a good chunk of stuff that's going on here. We have coefficients, we have a's, and we have b's. Thankfully, I don't have any exponents that are on the outside of these sets of parentheses, so I can go right into multiplying these two sets of parentheses together. Now again, I think it's very helpful to take one line and quasi-rewrite these things so it's really clear what things are multiplying together and give us a better highlight of what properties are going to be showing up with the exponents and what exponents are and aren't going to be changing with one another. So I can write out that the coefficients are going to multiply together. I'm going to reorganize this because it's all multiplying here. So I can have 2 to the 5th, or 2 over 5, I should say, multiplying with 5. I have a to the 4th multiplying with a, so I can write that out. And then I have b to the 3rd multiplying with b to the 3rd. So notice how kind of like terms, what we saw in 6.1, I can put things that are going to multiply together and affect one another next to one another before I actually do any operations with them. Again, this is an optional rule. You do not have to do this. We can still get the same result without going through this step, but I think it's very helpful to see which numbers and exponents and bases are multiplying with one another and affecting one another and things like that. So 2 over 5 times 5, well, this 5 is implied to be over 1. So the 5s are going to cancel out. They each become 1s. And I'm going to get 2 times 1, which is going to give me 2. I have a to the 4th times a. Remember that a has an invisible 1 as an exponent. So a to the 4th times 1, or to a times a to the first. The exponents are going to add, and that's going to give me a to the fifth power. B to the third times b to the third. The bases are the same. They are multiplying, so I can use the product rule, and I can add the exponents together, and I'm going to get b to the sixth power. And here I have my final answer of 2a to the fifth, b to the sixth power. And bringing everything together for our 10th and final example with this video, we have the quantity 3x to the 11th times 4x squared y times the quantity negative y to the 7th power raised to the 4th power. So we're noticing here that we have an exponent on the outside of this set of parentheses. So as per PEMDAS in our order of operations, we need to work with exponents first, which means I need to deal just with this last expression and exponent before I can multiply everything together. So I'm going to rewrite these first two sets of parentheses exactly as they are because nothing's going to change there. Whoops, let's go with actual pen, not a highlighter here. There we go. So bringing the first two things down exactly as they are, and I'm going to deal with the final set of parentheses. This negative sign that we have here, what's the invisible number that's in front of this? Well, that's going to be that invisible 1. So I really have negative 1 times y to the 7th, and all of that's raised to the 4th power. So a negative 1 times negative 1, that's going to give me a positive. And then that times a negative 1 is going to give me a negative. And that times a negative 1 for the 4th time is going to give me a positive 1. Okay, so great. The numbers have been taken care of. I'm going to have a positive answer here. Y to the 7th raised to the 4th power. That's going to be using our power rule. So that means that the exponents are going to multiply. And I'm going to get y to the 28th in my final set of parentheses here. Now I have everything multiplying together, and I can multiply these things either all at once or I can do two of them at a time. I'm going to just do two at a time because I think that's a little bit easier, and we potentially lose getting mixed up along the way as a possibility. So 3x to the 11th times 4x squared y. We're just looking at these first two things. I have 3 times 4. That's going to give me 12. I have x to the 11th times x squared. That's going to give me x to the 13th power. I'm applying the product rule there for that one. And then I have this extra y that's left over at the very, very end here. And I've not done anything with this y to the 28th, so I'm just going to leave it there just for now. But I've simplified these first two down, and now I can simplify the last part, throwing that in there as well. So I don't have any coefficient that's going to change here. Technically there's a 1 if you wanted to write that in for yourself. You don't have to, and we generally don't see it written in that way, but it is technically there. So I'd have 12 times 1, which is just going to give me 12. I have x to the 13th power, which that's not really going to change at all, so that's going to just stay as x to the 13th. And then y to the first power times y to the 28th. That's going to be the product rule, and that's going to give me y to the 29th power. It's my final answer there. So bringing it all together, I have my final answer of 12x to the 13th, y to the 29th power. Again, it should be noted, as we see here, I cannot go into multiplying these things first. I have to deal with any exponents that are outside of these sets of parentheses before I can actually multiply the sets of parentheses together. That's PEMDAS, that's our order of operations. We must follow that as we are going through and simplifying these types of expressions down. As a recap of the material that we covered here today, we were working with multiplication properties with exponents. And we're focusing specifically on making sure that we are correctly identifying the base of exponents before we go through and do different operations. We had three main properties that we covered in the video. We had the product rule for when we are multiplying bases together. We had the power rule for when we have an exponent inside of parentheses being raised to a power. And then we had the product to a power, where I have two things that are multiplying together being raised to the m power or some exponent power there. Remember to be on the lookout for when we have negative signs showing up and bases, and are those negative signs inside of parentheses or outside of the parentheses. That's going to determine if the exponent affects that negative sign or not. We then went through and had 10 kind of an 11th bonus example showing up on how we can apply those rules and get to each of our answers. And we'll go ahead and scroll down if you would like some practice problems for yourself. Here's a few that you can go ahead and try. Make sure you're taking it slow and steady and following PEMDAS, our order of operations. Whenever we see the word simplify, we should always think right to our order of operations. PEMDAS is our go-to for that. So after you've hopefully tried these, we'll go ahead and get the answers here. And hopefully you're getting these same answers. If you aren't, make sure you're going back and checking to see what did and didn't go right or wrong. I generally tend to find the errors that show up are either negative signs, or we've not rewritten the problem in a line or two to fully track what we're doing from one line to the next. A lot of people want to rush through and over-apply these properties really quickly, and I would just recommend slowing down, write things out. 1-2 extra lines of just showing your work isn't going to hurt you, and I think you'll find that a lot of errors will be fixed as a result of that. But other than that, that is everything for our 6.2 material.